Hello everyone and welcome to my presentation about implants of a lifetime. I prepared this talk in honor of my grandfather who passed away a few days ago, and he always had problems with his knees and he didn't want to have to stress with an implant to maybe get operated and then get operated a second time or all the stuff. He didn't want to have this. So that's why I prepared a talk about implants who can last longer than the patient lives. Okay, let's get started. In the at first we have two implants I wanted to show you. At first here we have the knee implant. It comes right inside here. And here we have the hip implant. That's how it looks like. This thing here comes right inside the hip, and this one in the upper bone. And you can do stuff like with your normal leg. But however, this is not that important. But this is more important. So this shows us how an implant is being built. Here we have the substrate, which is supposed to be blue. And if everything over here is blue, then it means the substrate is alright. Here we have the first layer. That's what is protecting. That is what is protecting the substrate from a counterpart, which is this thing. Now here we can see some other colors. These show us the stresses. The more red, the more dangerous it is. So this is the counterpart. As you can see here, it is being survived pretty good. The counterpart is being survived pretty good. The counterpart can be like the other part of the implant. So, but it could be anything else. So. Now in the second picture, we see it's like when a patient misses a stair or something like this happens as a patient hops. This could happen. Again, here we have our counterpart, and here we can see now something black. This means that the substrate is getting damaged here. I marked it for you with black dots. So here we can see plastic flow in the substrate. The first layer is alright because it can survive even higher pressure, but the substrate can't, so it starts to break earlier than the first layer. So what actually happened in these two pictures? They were the same models, but somehow in the first picture it survived, the implant survived, and in the second picture it didn't. Why? So I'm gonna solve this problem for you. The only thing, so here we have the first picture again. It was a 10 micrometer indenter. We pressed on this, the surface of the implant. And here, in the second picture, it was a 30 micrometer indenter. So, but this doesn't solve our problem what actually happened in these two pictures. Maybe you've already read this. It tells us that not the strength, not the strength, but not the force matters. It matters too, but more important is the contact area radius of the implant pressing on the surface of the implant. So the bigger it is, the more damage it will make. Here we can see the worst case scenario, which has been tested, and it was made with so the 200 micrometer indenter pressed on it, so that 21 micrometer contact area size appeared right here, and it is a whole mess. So the whole substrate is getting destroyed even very deep. So yeah, here we have a little graph. I wanted to show you that I can prove to you that not the stress matters, but the contact area size. So here is our 10 micrometer indenter. It had a stress of 28 gigapascals and it was survived. It was being survived. In our 30 micrometer indenter, we had 22 GPa, and as you can remember, the substrate was being damaged. So yeah, not good at all. And this is the worst case scenario with only 9 GPa, and it was a whole mess. So here we can see the contact area sizes, and we see that they matter. Here we have a 3.2 micrometer contact area size, and in the worst case scenario it was a 21 micrometer contact area size. And all of them were completely damaged, while this one was completely okay, even though it was 28 gigapascals. So yeah, I wanted to show you the worst case scenario. Here we can see the black dots. It is massive, it is a whole mess, and yeah, this is like the worst case scenario. Here I wanted to show you the worst case scenario in an little video. So yeah, the counterpart, which is maybe the other part of the implant, is pressing here on the surface of the other part of the implant, of the second part of the implant. And here we have our first layer, which is completely fine. And everything which is black, right here, is broken or starts a plastic flow, which then will start cracking and so on, so on. So yeah, because of all this happening, the biological tissue around the implant becomes poisoned and necrotic. And that's why patients have to be operated a second time to get this removed. Here we can see an operation where the necrotic biological tissue is being removed. So yeah, not good. But we have a solution, and this is it. Here we can see the only thing we did was adding a second layer. This was everything. And as you can see here, the substrate is completely fine. It is in all green, all okay. And yeah, because of the second layer makes a difference. So yeah, I also have a video for this one. Here it is. Again, the counterpart is pressing on the surface of the implant, and yeah, we can see a little bit, it is getting a little bit even yellow here, but it is still all okay, and it is not breaking it's all because of the second layer, because it's holding off the whole stress. So yeah, this is the solution. We also have a comparison here to show you how good our solution already is. Here the only thing we did here was the second layer, and our solution is surviving the worst case scenario. And here, these are the implants of today, and we already saw this picture. It is a whole mess. However, if you even want to have more protection, like here, you can see there is no green, it is all okay, it is all very good. It's all because of these few little layers between the first and the second layer. This is the first layer, this is the second, and we just added some small layers right here. Also, we added a top layer right here, but this is unimportant. We are more concentrating on this ones because they are making even better, more difference. If you want to have even more protection, you could also add some right here in between the second layer and the substrate, but you don't have to. We also have an animation for this one, and yeah, here's our improved solution. And you will see that nothing, it is almost not being touched. The substrate is almost not being touched. Here it's looking kind of bad, but this is unimportant because the layers can survive this. Even better would be our improved solution, but built with intrinsic stresses, so that you, while you're building them, or before you're building them, put them under stress. Then you will see this, and it is even better. We can see a little bit shaking on the top, but this is unimportant. But it is even better. Not even you can see here, this one was the big layer, and it is all okay. It is not even being really touched, only a little bit green over here, but the substrate is completely okay. So yeah, this was basically my talk. I hope you liked it, and if you have any questions, then write them down in the comments. And I would appreciate if you would leave a like, and yeah, thank you for watching.